Welcome to Tech Lab by Sid. Introduction to Interpreter. An interpreter is a type of program that directly executes instructions written in a programming language without compiling them into machine code first. Instead of converting the entire program into machine code at once, an interpreter translates and executes the code line by line or statement by statement. This allows for immediate execution, but can result in slower performance compared to compiled programs. Key components of an interpreter. Source code. The high-level human-readable code written by the programmer, which the interpreter will execute. Tokenization. The interpreter breaks down the source code into tokens, or meaningful units, such as keywords, operators, and identifiers. Execution. The interpreter directly executes the statements of the code after translating them into an intermediate form or machine-level instructions. Runtime environment. The environment in which the interpreted code runs, including memory allocation, variable storage, and function execution. Phases of interpretation. Lexical analysis. The interpreter scans the source code and breaks it into tokens, identifying elements such as keywords, operators, and variables. Syntax analysis. The interpreter checks the structure of the code to ensure that it follows the syntax rules of the programming language. It may build an abstract syntax tree, or AST, or similar structure for better understanding. Semantic analysis. The interpreter checks for logical errors in the code and validates that variables are declared before use and that function calls are correct. Interpretation and execution. Unlike a compiler, which produces a separate output file, the interpreter directly executes the code line by line, converting each line into machine-readable instructions and executing them in real time. Types of interpreters. Single-pass interpreter. The interpreter reads and executes each line of code once. It doesn't keep the source code in memory for later use. Bytecode interpreter. This type of interpreter translates the high-level code into an intermediate bytecode, which is then executed by a virtual machine. For example, Python uses this approach. Just-in-time JIT interpreter. Some interpreters use JIT compilation to compile code at runtime. This provides faster execution by compiling frequently used parts of the code into machine code during execution, combining the benefits of both interpretation and compilation. Tree-walking interpreter. Executes code directly from the abstract syntax tree, or AST, one node at a time, walking through the structure of the code. Advantages of using an interpreter. Ease of debugging. Interpreters allow for easier debugging since they execute code line by line. Errors are encountered immediately, allowing programmers to identify and fix problems quickly. Platform independence. Since interpreters read source code directly, a program can run on any machine with the appropriate interpreter, providing platform independence without the need for recompilation. Immediate execution. Code can be executed directly without waiting for an entire compilation process, which is ideal for rapid testing and development. Memory efficiency. Interpreters typically do not require a significant amount of memory to execute the program, as they don't generate a machine code file or store intermediate code. Disadvantages of using an interpreter. Slower execution. Interpreted code tends to run slower than compiled code because the interpreter translates and executes code line by line, rather than converting it all into machine code at once. No permanent executable. Interpreters don't produce a standalone executable file. Every time the program runs, the interpreter must be involved in the execution process. Less optimization. Interpreters typically don't optimize code as efficiently as compilers. Code runs directly without the intermediate optimization steps that a compiler provides. Dependency on interpreter. Programs written for an interpreted language require the appropriate interpreter installed on any machine where they need to run. Features of an interpreter. Line-by-line execution. Interpreters process code line by line, making it possible to execute programs interactively and debug errors in real time. Error reporting. Interpreters report errors immediately as they execute each line of code, helping programmers identify problems at specific points in the program. Interactive mode. Many interpreters allow for an interactive mode, example, Python's interactive shell, where code can be tested and executed on the fly without the need to write an entire program. No intermediate files. Unlike compilers, interpreters do not generate intermediate object or machine code files. The source code is directly executed. Dynamic typing. Interpreted languages often support dynamic typing, meaning types are assigned at runtime rather than compile time, providing flexibility in programming. How an interpreter works. Input. The source code is given to the interpreter. Lexical analysis. The interpreter breaks down the source code into tokens for easy understanding. Syntax and semantic analysis. The interpreter checks the syntax and logic of the code, building an abstract syntax tree or similar structure. Execution. The interpreter executes each line of code, translating it into machine instructions and running it in real time. Error handling. Errors are reported immediately when encountered during execution, allowing for quick debugging. Applications of interpreters. Scripting languages. Interpreters are widely used for scripting languages like Python, Ruby, JavaScript, and PHP, where rapid development and testing are crucial. Interactive development. Interactive environments, such as REPL or readable print loop systems, often rely on interpreters to allow for immediate feedback on code execution. Educational purposes. Interpreted languages like Python are often used in education due to their ease of use, immediate feedback, and suitability for beginners. Web development. Many web programming languages, such as JavaScript, rely on interpreters within web browsers to execute code on the client side. Here is a comparison of interpreter and compiler. An interpreter executes code line by line, whereas a compiler translates entire code into machine code before execution. There is slower execution in interpreter due to line-by-line translation, whereas in case of compiler the faster execution since code is already compiled. In interpreter, errors are reported immediately, whereas in case of compiler, errors are detected after compilation. Interpreter do not creates standalone output file, whereas compiler produces an executable file. Interpreter generally requires less memory, whereas compiler uses more memory due to intermediate code generation. To summarize, an interpreter is a program that reads and executes source code line by line, providing immediate feedback and enabling easy debugging. It is highly beneficial for tasks requiring rapid development, real-time error reporting, and cross-platform execution. However, interpreters generally lead to slower execution speeds and lack the optimization that compilers provide. They are particularly useful in scripting, web development, and educational environments where code needs to be executed interactively or immediately tested. While interpreters have their limitations in terms of performance and efficiency, their ability to handle dynamic and interactive environments makes them a valuable tool in the software development lifecycle. Thanks for watching the video.